Good morning. I think we're about ready to get started. My name is Cameron Broder, and I'm a program manager from the Windows Hardware Developer Experience Device Foundation Platform team. And it's quite a mouthful, but we're really the Windows plug-and-play team. We specialize in the device installation, discovery, and association of all devices with Windows. And with me this morning is Adam.
Yeah, good morning. My name is Adam Lennard, and I'm a software engineer on the same team.
And I'd just like to welcome you all for coming to this Chalk Talk. And we're going to give you an opportunity to ask questions. This is really your talk, an opportunity to get everything that might be on your mind, those questions answered from myself, Adam, and there are also other members of my team in the room. So before we get to your questions, we want to spend a little bit of time talking about what makes a device installation great. And we'll also get into some more detail about a few of the things you've heard of in prior talks at Build, especially how to improve the installation performance of devices, that's device configuration, as well as how to take advantage of the new Metro-style applications with devices. And then we'll also have a very short demo about some of the ways that you can diagnose common device problems that you might be seeing as you're developing drivers and driver packages. And then finally, the bulk of the talk will then be an opportunity for all of you to ask those questions. Real quick, I'd like to highlight several sessions that were given throughout the Build conference. The four core sessions that relate to device installation were given over the past 2 days. Did any of you just come out of Chad's talk, simplifying, or it was, I'm sorry, best practices for packaging and distributing device drivers? Yes? See, quite a few of you did. That's great. That's great. So, again, that talk as well as the other ones that you see here, that's you might want to go, if you haven't had a chance to watch those, you can see those online. So what makes a device installation great? And one thing that we've driven home, I think, over the last few days is that the best device experiences are designed. And that starts from setup to software. So from the beginning to end, when you are developing your hardware and the drivers and the associated software with that device, you need to really be cognizant of the entire experience and how to deliver the optimal experience given all of those variables. And we're going to touch on two of those aspects to make that experience truly great. One of those is speed. And speed is of the essence. We want to ensure that your devices, when they're attached to the PC, that they're installed as quickly as possible and available for the user. And then second, we want to also encourage you to make use of Metro-style applications because you can create Metro apps now to work with your devices and get the full, rich Windows 8 experience. So here you can see a graph that shows the relative device installation performance over several past releases of Windows. And in red, you see device installation. And that's the traditional plug-and-play device installation that everyone is familiar with. It's been around now since Windows 95. Performance has improved over the years through a variety of the different releases. But you can see that it's still relatively can be an expensive process in terms of the performance and the time that it takes to complete the device installation. In Windows 8, we've made significant performance improvements in a feature that we call device configuration. And device configuration basically represents a radical performance increase for the installation process. Order of magnitude or more of a speed increase. So your devices, if they conform to the device configuration requirements, could install in as little as 100 milliseconds or maybe slightly more than that. So it is quite a big difference. And with that, I'm going to let Adam actually talk us through how the device installation and configuration experiences work. So Adam?
Great, thanks, Cameron. So before we go into exactly what device configuration is, I'd like to kind of give a little bit of background about exactly how device installation works for anybody who's not that familiar with it. And in order to do that, I'd like to start with giving some background about the driver store. So basically, the driver store is something that we introduced back in Windows Vista. It's essentially a repository of all drivers that are available for installation. And so it is actually populated with drivers from a number of different sources. So mainly, it starts out with all of our Windows inbox drivers, which that basically includes a lot of our class drivers for very basic device functionality, as well as a couple of drivers that sort of enhance the experience for basically device classes like video or networking that you sort of want to work really well right out of the box before better drivers are available. So another place where drivers can come from is during Windows setup. You're able to basically, if for example you need to be able to install Windows on some kind of a device that has some kind of a modern storage controller that Windows might not actually have built-in inbox drivers for, you can always provision drivers there with your own media or something like that. And also, if you're doing an upgrade from Windows Vista or Windows 7, then a lot of those OEM third-party drivers that you had back on Windows 7 will actually get migrated into the baseline Windows 8 image as you're first installing. Another place, of course, is through an unattended setup. So this often happens on the factory floor. An OEM might actually have a whole bunch of initial drivers that they need to get into the box to support a lot of the custom hardware that they ship with. In addition to that, we have a whole variety of offline scenarios where basically you can inject drivers into offline images using the OEM pre-install kit, the OPK kit, and a variety of other tools. Of course, we've got Windows Update, which is one of the most popular places where drivers come down from. Usually, most systems get by with just inbox support and Windows Update support. And finally, we have software installers. So if basically you want to provide some additional installation experience around your device, then you can create a software installer, and you can use that to actually pre-install, pre-inject drivers into the system prior to exposing device functionality. So, moving on, how does device installation actually work? Well, basically, it's the process of matching the most appropriate driver to a given device and then installing that driver onto the device so that the device can be started, can expose some interfaces, and begin communicating with the operating system or your applications. So how does this all happen? So when a device is initially enumerated, we don't really know anything about it other than a couple of things that we can query from it. So this is where we basically interrogate the device for things like capabilities, but in particular, we ask it for its hardware and compatible IDs. So this is basically, these are the IDs that allow us to match a device to a driver. And so the way that happens is because we already have this driver store and we have a whole bunch of driver packages already in there, we have them pre-indexed, so all of their hardware IDs and compatible IDs can be looked up really quickly. And so as you know, you can provide hardware ID matches that are extremely specific on the order of basically something like the make, model, maybe a revision, or you can do something a lot more generic, like just say that I just want to match on a basic class driver for like a mouse or keyboard or network adapter. So basically, we could actually turn up with multiple potentially matching drivers within the driver store. So this is where we have to actually pick only one driver, because you can only have one driver installed on a device at any given time. So this is where we basically perform our driver ranking and matching, where the idea here is basically the driver that most closely matches the hardware and compatible IDs, and of course has proper signing information, highest version, and all of that will end up winning. So once we've basically selected the driver, now we can begin installing it. So the act of installing really just boils down to a couple of simple operations. We need to basically copy out your driver files to their target runtime location. We need to add all of the services, which basically represent the drivers. So these are the services that are tied to those driver binaries. And then in addition to that, we need to add any number of custom settings that you might have for the service or for the actual device itself. Those three components essentially create what we refer to as a driver configuration. So also, while all of this is happening, we allow class and co-installers to basically hook all of these operations in kind of a lockstep fashion, where anything related to files can be hooked and modified, services can be hooked and modifying, additional settings can be changed. Basically, anything you want can be sort of done with class and co-installers. It provides a abnormally extensive amount of additional functionality that you could add during your installation. However, of course, it does have all kinds of problems with stability, robustness, and things like that, just because there are all kinds of different environments that device installation can happen in, and often class and co-installers might overlook some of these and potentially cause device installation problems. But essentially, once we've done all that, then we're able to basically fully start our device up, and the user is able to start using it. So another important thing to mention about this system is that we basically have to run through all of these steps every time that a brand new device is connected. So this means that we're actually opening up the INF file, which is essentially a text file that just has a whole bunch of these installation instructions. We have to copy files, register services. We have to do all of that work. And even if you've plugged the device in before and maybe you have another copy of this device, maybe you have two devices that are the same, every time that you have to connect a new one, you're going to have to repeat a lot of these steps. So it's a little wasteful, but that's sort of traditionally been the model. So keeping that in mind, what we've done with device configuration is we've sort of turned the device installation model on its side and said that a lot of these operations that happen only once the device actually arrives in the system, we can actually do a lot of those ahead of time, because we already have that full driver. We have all of the settings. All of that is already there inside the driver package, just the device hasn't actually showed up. So what we can do is we can pre-process the INF file. We can copy the files out ahead of time. We can pre-register the services. We can take all of the settings. We can parse them and already sort of pre-populate them into a place within the registry, so that they're sitting there kind of dormant and waiting for a device to actually show up. So we're basically doing the most expensive part of device installation away from the actual device installation process. So this can basically be done offline, and we can basically do it for a lot of devices or a lot of drivers on the system. So we can do all of this ahead of time. In particular, if you're using a lot of the offline imaging, or you're doing unattended setup on the factory floor, you can actually do the most expensive work related to device installation. You can do it all offline before the user ever connects anything. So what this basically gives us is now, when the device shows up, all we have to do is just quickly rank it, and we already have this sort of shell or template of what an entire driver configuration represents. So we're able to just sort of take it, quickly apply it to the device in a matter of milliseconds, and fire the device up. So in the end, what this ends up giving you is an experience that is very similar to if you had already plugged the device in and it had already gone through device installation, and then you've unplugged it and plugged it back in. So it's like basically the act of installation is sort of negligible. It's almost as if the device was already kind of designed and pre-installed with that system, even though it wasn't. So some of the motivation behind device configuration. Basically, if you look back at device installation and how long the model has sort of stayed that way, a lot of it kind of stems back to a time when a lot of the devices and a lot of the kind of extensibility in terms of hardware was done to systems using like PCI expansion cards, jumpered, different types of devices where you'd have to like crack the computer case open to like add a CD-ROM drive or new sound card or something like that. So basically, that was sort of the heavy lifting part of the device installation experience for most users. So the fact that when they had completed all that, they power their system on, and they had to sort of walk through this like installation wizard or wait a little longer to get the driver installed on there, that wasn't as big of a hit in the mind of the user. But these days, with the creation and sort of popularization of USB devices and all sorts of different network-connected devices, the actual act of getting a device connected to a system is pretty instantaneous. You just sort of plug it in, and if after that the user has to wait a little longer than it took to actually plug the device in, then the overall perception is that device installation takes long. So that was sort of the motivation, and clearly we're definitely moving towards more lightweight form factors, including netbooks and tablets over here. And then also it's important to call out that we've also got this new feature called Windows to Go, where basically you're able to install an entire Windows OS onto your USB flash drive. And because basically you're going to be plugging this into all kinds of different hardware configurations, the faster that we can bring up all of those devices, including, of course, including any like input peripherals and anything that is sort of added onto the system later on. But you also want to be able to bring up all of the core devices, like you want to be able to bring up the PCI bus, all of your storage controllers, your hard disks, USB host controllers, all of that sort of core infrastructure that all of the rest of your devices are attached to. And typical systems have like hundreds of these devices, so it's something that any improvement we can make to how quickly it takes to install that, it makes it a lot quicker for you to actually get a Windows to Go system running on any new hardware. So some of the classes that we've focused on here have definitely been around popular peripheral devices that users are often connecting and disconnecting from their systems, in particular input devices. So that can be keyboards, mice, different types of pointing devices, different types of HID-compliant devices, storage devices, of course, in the form of USB mass storage devices and CD-ROM drives, whatever. And, of course, boot devices, as I mentioned, so anything that sort of helps bring the system up quicker is definitely something to take advantage of. And then, of course, a small variety of other select devices. So basically, I will now turn it over to Cameron, who will basically help us go over how you actually support device configuration.
Great. Thanks, Adam. So we've all seen now exactly what device configuration is and how it provides a pretty substantial performance improvement over traditional device installation. So you're probably wondering, well, what do I have to do in order to get this great performance? And there are new Windows certification tests that we're putting in place, and those tests actually outline in detail exactly what you need to do in order to ensure you get that great performance. And those will be published in a certification requirements preview that will be coming out shortly after this conference ends. The things that you need to watch out for. This is a list of the various things that you might have in your driver package which would prevent you from being a configurable device. And so just real quickly, we'll go through these. The first is the use of a co-installer or custom class installer. And so co-installers or custom class installers, those represent something that is non-deterministic, and we as the plug-and-play subsystem are unable to do any pre-processing for them because anything could occur in the context of one of those co or class installers. So avoiding those is a best practice. Also, there are a number of INF directives which are not related directly to device installation. And that list is in the requirements preview document. But really what you want to focus on is just making sure that your driver package and the INF file itself is really just targeted to installing the device, that you're not trying to do anything else outside of that domain. Also, deleting or modifying registry entries, files, or services, that's another thing that you'll want to avoid. And when you're adding registries through the add reg directive, only specify the HK relative path for those registry keys. And that allows Plug and Play to actually manage where those registry settings will go. And then only copy files to the System32 or the System32 drivers directories. So those are the dir IDs 11 and 12. And as long as you copy your files out in the copy files section using one of those locations, you're going to be great. Also, you'll want to specify PNP lockdown 1, and this is in the version section of the INF file. And I'll talk a little bit about that in just a moment. And then only install driver-related services. So that would be drivers, kernel drivers, and I believe file system drivers are the 3 services.
Yeah, basically we're sticking to just kernel drivers. We
That's
want to
right.
avoid Win32 drivers. That's
Yes. And so you'll want to just keep your INF only installing those service types. And then finally, when you're targeting the OS version decoration, don't include the product type or suite mask flags as a part of that decoration. So real quick, I'm just going to run through a super simple INF file. And this represents really what is the smallest INF file that you probably could create for your device. And the important things to note are commented here. So just some, again, best practices. Always make sure that you have updated the date version with every change that you make to your driver package. That way we can perform the driver ranking appropriately and ensure that the best driver is selected for your device. And then always, of course, ensure that you sign your INF file and your driver package. And that's going to be done automatically through Woo, or I should say, through the WinQual service when you submit for certification. But it is important to ensure that you are a signed driver. And the PNP lockdown equal to 1. So that basically protects your driver files from tampering. And it indicates to Windows that we're going to maintain that set of files and we're not going to let anyone else touch it. And then explicitly target the platform architecture in the manufacturer section. So in this particular case, we're targeting an x86 architecture. And here, this is the copy files section of our INF file. And again, just keeping it really, really simple. The copy files actually, in this case, is just copying the driver.sys file. So this is a really, really simple one. And again, if you notice at the bottom, the default destination directory for this file is going to be durid12, which corresponds to the Windows directory System32 drivers. Here we're applying settings. So we're doing the add_reg directives. And we have an example here of just adding one single registry value. And this is going, again, into the HKey relative root path. And so plug and play will maintain that. And yeah, so just keeping it in the HKR key is a good practice. And then we get to the services. And so here we're just adding a kernel driver service. We're setting it for system start, and that's it. Real simple. And just so that you know, WDF is still fully supported. So if you're using that driver model, you'll be able to take advantage of the device configuration feature. So I spoke earlier just about the performance of device configuration. The second piece that we want to highlight is the app experience. And over the last few days, we've really, you've seen a lot about Metro-style apps and how great they are and how great they can be for your devices. And that's what we really want to encourage you to leverage, is creating Metro-style apps for your device. These provide a number of advantages over the traditional desktop apps. You get automatic download and setup, so it's very easy. It's great for your users. And there are a number of built-in experiences which you can leverage for a variety of device classes. So there are built-in experiences for printers, webcams, mobile broadband SIMs. And then we also provide support for custom applications. And there was a talk, I believe it was yesterday afternoon, by my colleague George Roussos. And George explained how it's possible to extend the app experience to a Metro-style app for a custom device. And so you're able to write a custom app experience for WP devices. WPD is Windows Portable Devices, if you're using that framework. If you're using the Windows.Storage or Windows.Networking APIs that are part of the WinRT API set, you'll be able to use that as part of delivering a custom app experience. And then finally, you'll be able to use device I/O control if you need to really get down deep and control various aspects of your custom driver. You have that full capability available to you. And just real quick, this is just illustrating that with Metro-style devices, or Metro-style apps for devices, the driver package itself, we want to keep that small, and so just limit it to the driver itself. And then once the driver is actually downloaded, at the same time, we're also going to be going up to the Windows Store to retrieve the Metro-style app for your device. And this will all happen automatically and very quickly. And we do have the traditional desktop experience available as well, and Adam's going to talk a little bit about that for us.
Yeah, so basically, if you guys are still keen on developing apps for the software, for the desktop environment, then basically along the same lines as Metro-style apps, we do want those applications decoupled from the drivers themselves, definitely to get a lot of those benefits in terms of faster download times and better layering. But basically, the way you do that for desktop software is we recommend the use of the request additional software INF directive. And this basically, I'll get into more about exactly how this looks on the next slide. But basically, the way that it works is for a given INF file, you basically say that this INF file should request additional software, where the additional software doesn't necessarily have to be there right away. So it's a very loose coupling. But basically, the idea is that any device that is installed with an INF file that does request additional software will result in that device generating a Windows error report that basically goes up to us and goes up to our back end and queries it to basically figure out if any additional software is actually available. And that would be software that you guys can basically you can map a software solution to a given set of hardware IDs. So the way it would look like is on the back end, you'd use the WinQual website to basically say, okay, here is my well-known hardware ID that defines my my manufacturer, my model, and all of that. And to that, you can basically tie a solution that provides a link to a website where people can go and download your value-added software if they need to. So again, because Metro-style apps are going to sort of be the predominant style of apps in Windows 8, it's possible that a lot of new users might not really be going to the desktop that much, or maybe not even at all. So it's something that we really don't want to waste their bandwidth having to pull down all of this additional desktop software if they don't need it. So we kind of want to put the control back in the user's hands there. So the way that basically looks is in the INF file, there's a control flag section. And so you can basically just say request additional software for asterisk, meaning all device models exposed by this driver, or you can basically specify specific device hardware and compatible IDs. So within a package, if you have a number of different hardware compatible IDs, but you only want a certain one of those drivers to actually request additional software and none for the others, then you can do it at that granularity. And of course, request additional software has been available since Windows 7. So if you're still creating driver packages and you might have wanted to bundle them with software, but you also want them to work well in Windows 8, then you still can basically create packages even for Windows 7 that will work well all the way through into Windows 8 and beyond. So moving beyond that, I just wanted to give you guys a little demo about some of the improvements we've made to being able to diagnose devices in Windows, or to diagnose device problems in Windows 8. So what I'll do here is basically, so our new devices and printers folder, which we introduced in Windows 7, is sort of the simpler way of basically viewing all of your devices. So you can either start right from here, where basically say that we're talking about this mouse over here that I'm using, and you're basically developing a driver for it, or you're updating drivers, or you're just trying to kind of figure out exactly what happened to this device. How did it get into the state that it's in right now? So in the past, you would have looked inside maybe the setup API.dev.log file, if you guys are familiar with that. That is still there, and that will still contain information related to traditional device installations. So whenever one of these traditional class and co-installer based device installations happens, it is still going to be recorded inside the setup API log as before. However, anything that goes through device configuration, because it's an entirely different model that lives outside of the setup API domain, all of that actual configuration happens really quickly and inside the kernel. So basically, we provide basic events that get logged in order to find out what actually happened during one of these installations. And because there aren't really many points of failure during this, it's really just the case that you want to figure out what kind of driver got onto there. So either going through Device Manager and finding the properties of your device, or if you start from the Hardware tab over here in Device Manager, let's say that we wanted to find out what happened to this particular mouse device node. How how did we get the current driver that's onto there. So we'll open this up. This will take us to the Device Manager Properties tab, the same one that you'd get there from Device Manager. And you'll notice actually that we have a new tab here called the Events tab. And so this basically will show a chronological listing of a lot of the device installation and configuration related events that happened to this device that got it into the current state. So what we can see here actually is initially when this device was plugged in, we configured it with our inbox MS class, or our MS Mouse inbox class driver, and we started it. That all happened no problem. Then after that, it looks like actually we got a new driver, likely came down from Windows Update, and we now updated the device with that driver. So if you actually want to dig in and get a little more information about that, all of these events are actually all regular Windows event log style events. So when we open that up, basically we get a scoped view over here within the event viewer. So this is the same event viewer control panel view that you can get into, but we've sort of pre-scoped it to just this device. So now you can actually look at all of these events. And so let's say that we wanted to figure out how the first installation happened. So we have basic details about this particular device instance was configured with MS Mouse, and this was the particular section or driver configuration that was used. But if we want to dig in a little deeper and get more details, then we have a whole bunch of more specific events here. So we get information about what particular class that device was. That was the mouse class. We get its driver, date and version information, provider section, and very important, we get the actual driver rank value. So this basically helps you figure out exactly why this particular driver might have been picked over another driver. And of course, the actual ID that we matched on. So this is all something that is sort of like a first line of diagnostics. Usually this might be enough to actually figure out exactly what happened. If not, you can always drill down a little deeper inside some of the setup API log files if required. So I suppose at this point,
yeah, at this point, we're going to open up the floor to questions. So, yes, right here.
Yeah, you didn't show device stage, so it's still there?
Yes, device stage is still there. That's correct.
yeah,
And this actually does have a device stage experience.
Yep.
Yes, right here.
Provide a little more detail on this magical pre-copying of files that happens?
Okay, so the question was, can we provide a little bit more detail on how the copying occurs in device configuration?
Yeah. So,
or
Whatever during device configuration, since the files have already been copied somewhere.
right. So basically, during regular device installation, we take those files and we pre-copy them, or we copy them to their target runtime location under the Windows System 32 drivers folder. During device configuration, when we're preparing or when we're pre-configuring a driver, we basically copy those binaries out there and we create those services. So all of that actually happens ahead of time.
I'm confused. The copying of files happens during installation or during configuration?
So if we're dealing with device installation, it happens during device installation. If we're dealing with device configuration, then we do it ahead of time. So it happens prior to the device ever even being connected to the system.
So all the files are really in those directories?
Yeah,
So
they
will contain a large number of driver files?
they will contain, yes, that's correct. They're already kind of dormant, waiting. Yeah.
I suspect maybe they were being copied to some folder somewhere else, and then eventually links got it.
No, we're putting them right where they're going to eventually end up. Yeah.
right here.
You mentioned earlier that this is similar to having the device actually have it like as if it had been plugged in and now it's unplugged.
Right.
So you plug it. Does it mean that you actually create dev nodes, pre-create dev nodes?
Oh no. Dev nodes. So dev nodes are not created ahead of time. So as you're aware, if you've ever plugged a device in and then unplugged it, the next time that you plug that device in, you don't need to go through device installation because we've basically cached away all of that device state for that particular device instance or device node, so that when you plug it back in, it's all sitting there ready and waiting for that device to come back. With device configuration, we basically pre-process the INF and generate the exact same kind of settings that would live there underneath a device node, except that we keep them off in a different location. So basically, as part of the driver store and some of its indexed information, we basically have another repository within the registry that is sort of like a driver database, where we have all of these kind of device configuration templates are sitting there, and they're just waiting to just be quickly copied over onto a device node.
So the device node will be created after you buy.
That's right, yeah.
So along the same question, that's only for certain types of devices, though. Is that true?
That's correct.
So how did you determine which devices?
We basically, the way that we started, because it's a big undertaking to go and do it for every single device across the board, because there are a lot of compatibility implications, and of course we're trying to basically introduce this feature in sort of like a retroactive manner, where it's like there already are a lot of drivers out there that have always been doing things in a very simple way, so why not just start kind of supporting them retroactively? So basically what we did was we used telemetry information about previous OSs to basically see what types of devices are most commonly connected after the operating system has been used. And that led us to discover that sort of the high hitters were basically people connecting mice, keyboards, USB storage, a lot of these types of peripheral devices.
Is there a way to request or a methodology to request that a certain type of device be added?
It's more something that will come with future OS releases. So it's something that we will continue looking at, and we'll continue basically adding more support as things move on.
Yeah, and we also did spend some time looking at boot devices as well, so that we can get the first boot experience, that time, minimized as much as possible. So
yeah. So there are actually a lot of devices which, even back in XP, Vista, Windows 7, that need to be configured, at least in a very minimal way, in order to even boot the system. So if you're bringing the system up from nothing, you start from your ACPI device, exposes a PCI bus, then maybe some storage controller, exposes some kind of a disk, which then exposes a volume, and that's kind of what you need in order to initiate the boot process. So we need to actually be able to take those drivers, and in like a minimal form, we need to be able to configure them so that we can get that far, so that we can actually perform real device installation on them. And so the added benefit that we have here with device configuration is that really early on during boot, prior to having all the rich kind of facilities for performing device installation with class and co-installers, we're able to actually do full-blown device configuration during boot time. So those devices will not need to be patched up later on. It all happens up front.
And what do you call this feature? Just device configuration? If I were referencing it to somebody, how would I call it?
Yeah, we were calling it device configuration.
yeah, that's how we would refer to it.
It's,
I'm sorry, yes. The question was what device classes are available for use with the device configuration feature. Yes, right here.
You had one slide that talked about certification requirements, and then the next slide you were talking about best practices.
Yes.
Which of these things, like for example, let's just take an example of not having Del-Reg sections.
Yes.
Is that a recommendation or is it a logo requirement?
So it is a certification requirement, and on two of those platforms, x86 and x64, it's for Windows 8 a recommendation. It will not be strictly enforced. So when you actually run your device through the certification tools, you will, if you do have, for example, a Del-Reg section, it will generate an error. However, that error is filtered out from the results, which are then sent up to WinQual. So basically, it warns you that in the future, we are considering removing Del-Reg, for example, as an INF directive, as that you should be using, and just to let you know. But you'll still receive a certificate certified device and get signed and be deployable by Woo. Yes.
Right. No, so the question basically is when you plug a device in to even a Vista or Windows 7 system, when you plug a device in for the first time and then you unplug it and then you plug that device in, that state that basically gets cached during that initial device installation, that's how plug and play has always worked. So you really only need to go through device installation one time, only the first time that a device is connected. So device configuration gives you the benefit that even that initial time that you're plugging in the device before the system has ever seen it, that's going to be fast too. That's going to be as fast as if you had plugged the device in before. So users won't really notice. So in essence, what it does is it sort of makes the process of device installation kind of invisible to the user. Because as far as they know, that device just always worked with that system, and it's just always been that way.
So Windows 8 is improved that process.
Exactly.
How do you feature?
When,
I got it.
yeah.
Okay. My second question that you asked for the request additional software to be in the IF file, so
Yes.
you can include the third party's application.
Right.
So can you extend that request additional software to the device too? Because some third party's device may be big as maybe 2 gig or 3 gig, and my drive package probably just a computer drive, very small, but I need to include the third party's drive package, not application drive package. So right now, I only can do is inbox driver. I cannot do the third party's driver. So is any way you're going to extend it to support third party's driver? So you have
I'm
to
not-
include, right? You have the IF file for your device,
Right.
but your device just a computer drive, correct? So you have functional drive. The functional drive is huge.
Okay.
Third parties, and they also went through the certification,
Okay.
signed, and
Okay.
so they are working fine. Right. We only need one particular device support by the third party.
Mm-hmm.
So right now, there's no any way that I can just say I just need a portion of that device driver.
Okay, so basically the question is there a way to basically reference from your own third-party driver package, is there a way to reference another third-party driver package so that you don't have to basically redo everything that they've done?
Yeah.
So traditionally, we've only supported that for inbox drivers. So inbox drivers, if you're familiar with the include and needs directive, yeah, basically that is strictly limited to inbox drivers. We unfortunately don't have any support for doing that across OEM drivers.
Yeah, so right now you're asked to make the driver smaller, but I need to include a huge drive package from other OEM.
Mm-hmm.
So is there any way, I know you are not supported on the Windows 8. Moving forward,
Well,
are
so
you consider doing that?
so basically, if that third party whose driver package you want to extend does provide a whole huge set of software,
Yes.
then they could use the request additional software directive, right? And then they could put that software up, and then all you would have to do is basically make sure that you yourself just include request additional software and perhaps work with that vendor whose driver package you're extending to make sure that they add in the applicability information of your particular device ID that differentiates your driver package from theirs.
Yeah.
And then that way the user will still get that solution for that big driver package.
I understand you're asking me to small guy, it's hard to ask them to change. So if you guys can provide something to include their draft package, that would be great.
That's great
Okay.
feedback.
Okay.
We can take that into consideration.
Right here.
Two questions. The first question is how does the separation of installation and configuration impact the offline injection scenario for drivers?
So,
Is there any difference or?
so the question is, how does the introduction of device configuration impact offline injection and related scenarios? So basically, when you're injecting a driver offline, all you're really doing is you're taking that driver and you're putting it into the driver store so that it's available for installation. Now, that part doesn't change at all. That's all strictly within the domain of the driver store and all of its maintenance routines. So the only thing that does slightly change is that when you're working with offline injection, the assumption is that the image that you're working with is an image that may have not actually been booted on a system yet. So that image needs to have all of the drivers that it might need in order to boot. They all need to be sort of pre-processed and ready to be used. So already back in Vista and Windows 7, there was sort of a primitive form of pre-processing that was going on in line with offline injection. So the way that this worked was basically if a driver belonged to a certain class of devices, so this was more like system devices, SCSI adapter, storage, anything that's very kind of core system related, those IMPs would basically undergo additional processing where we would do the same thing. We would basically copy their files out ahead of time, pre-register their services, although we didn't kind of do it entirely. So this device was sort of running in kind of like a bare bones mode where it was just sufficient to get the system booted, but then it was still required to go through device installation once you actually got the system booted. So with device configuration, if the driver is actually determined to be fully configurable, then we can basically pre-process it the same way offline, right? So we'd pre-process it, but we'd pre-process the additional driver settings and things that we weren't able to pre-process before the existence of device configuration, such that when you do actually boot this system up, if those particular devices that use those drivers do come up during the boot process, we will fully configure those devices so that once you get into the OS, once you've booted up fully, you don't need to do anything more to that device. So it is actually an optimization in that case.
Okay. So would that be part of the DISM call, or would that be an additional?
No, it happens automatically as part of doing DISM add driver, as long as the driver belongs to that class, automatically.
And then the other question was kind of around what he was talking about with that additional software stuff. How does that get impacted on the offline installations there? How does that work? Because you had said the user would have to request it. How?
So the user, so basically what happens there is by providing request additional software, we're really just saying that when that device is actually running on the system, we'll send a report up to Microsoft, to WinQual, and if there happens to be a solution available for that, then that will get presented to the user through the Action Center. And and so basically, if there was software that you sort of wanted to basically provide kind of ahead of time, like if you wanted to like pre-deploy that software so that the user didn't have to go and do it after the fact as they're getting their new system up and running, then you could basically pre-install that software into the image too, where that software can basically, again, it's up to the vendor of that software. If they provide a way to deploy that software offline, then that's great. If not, then you can always boot into the sysprep audit mode, where that's where you can basically install any applications that require like XZ driven installation. So you can do all of that, and then together with an actual solution that you'd put up on the WinQual site, tied back to the request additional software request, you can basically specify information that tells the system whether or not that software has already been installed. And that's done in the form of a registry key. So basically, if that software would have left something under, HKey local machine software, the vendor's name, then you can basically say, okay, if that key is already there, then don't even bother offering the solution. So that way the user won't get interrupted if the software is already there.
Do you have any guidelines about what you mean by additional software? Because, just to take as a random example, we've got a COM DLL for an API to our driver. We've got a control panel. We've got a
Right.
Helper app that runs in user mode that just happens to provide some of the core functionality of the driver. Are those additional software, or are they?
Technically, yes.
Okay.
So yeah, I think the answer is yes.
Although things like control panel applets and COM components, rather than using some of like the directives, like the register DLLs or things like that, you can actually express that using INF directives. So that's
Sure.
something that.
So those are considered okay things to install through your INF file, or not?
For those particular things, if sort of they really work kind of hand in hand with the driver, and without them the driver is essentially useless, then we can consider that to sort of be part of the driver. It's really more things that sort of extend the, I guess, like the base experience of the driver, value-added type of software.
So for driver configuration, you guys are essentially pre-populating a bunch of information. Does it have a ramification in terms of the OEM's image size?
I'm sorry, I didn't catch the question.
The OEM size of the image, standard image size, does it have a ramification on whether you load the image too much or?
Okay, so the question is basically, with all of this pre-configuration that we can do offline, does this have any impact on the initial size of the OEM's image? Yes, there is definitely some implication, but it's all very minimal. It's all really just expressed in the form of registry settings and maybe just one duplication of a driver file. So it really does come down to how many actual sort of extended drivers an OEM is going to pre-populate in their image. So it still is up to the OEM to kind of do the due diligence and still kind of keep the driver support kind of scaled back to really that specific image that's being deployed on that hardware. So it does have some implications, but it is minimal, but it's something that is totally in the hands of the OEM to control.
All right. Well, we're going to be around, for a few minutes after this talk. So if
you guys
any of you would like to come up and ask us questions one-on-one, we'll be more than happy to answer them. And I'd like to thank you all for coming.
Thank you.